It's 3 a.m. Something just broke, and the question isn't whether you tuned Fail2ban well, it's whether you can get it back. Everything you built across the first 10 lessons lives in just 5 places: jail.local, your filter and action directories, the SQLite database holding ban history, and the IP table's runtime state. Lose any of them to a crash, a bad RM, or a dying disk, and you've lost every custom filter and every IP you've ever caught. In this lesson, we'll cover exactly what to back up, automate it on a daily schedule, walk through 3 real disaster scenarios, and finish with cross-server blocklist sync. So let's triage. Your 3 criticals are jail.local, your custom filter.d local configs from lesson 08, and the custom actions from lesson 09. These change rarely, but cost you hours to rebuild, so back them up on every change. The SQLite database is high priority, daily. That's your ban history and recidiv memory. Logs are medium, weekly, useful for forensics but not for running. And the distro-shipped files, skip them entirely, including jail.conf, which gets overwritten on every package upgrade anyway. That's why your overrides always live in jail.local. Now let's look at what's actually inside that SQLite database, because once you know the schema, it stops being a black box. Open it with the SQLite 3 CLI, and you'll see 4 tables, but the 3 that matter are jails, bans, and BIPs. The jail definitions, every ban ever recorded, and the IPs currently serving time. From there, it's just SQL. You can pull your active bans, rank your worst repeat offenders for recidiv tuning, or count bans per jail over the last 24 hours, all without touching Fail2ban client. Now that you understand the database, let's automate protecting it. This script does 3 things. It uses SQLite 3's .backup command for a concurrent safe hot copy, critical because Fail2ban is actively writing, then tars your jail.local, every local filter, your custom actions, and the database snapshot into one dated archive. Finally, it prunes anything older than 30 days. Drop it in, USR local bin, add the cron line at 3 a.m., and your tuning history is safe. Backups protect one box, but the same ban data is valuable across your whole fleet. If Server A has spent a week learning which IPs are hammering SSH, Server B should benefit immediately. Pull the active list straight from Fail2ban client, or hit the SQLite database directly for every ban it's ever seen. Then SCP the file over, loop through it with banip, and verify the count matches. That's it. Institutional knowledge. Portable. Now let's talk about the disaster scenario. An ops engineer runs a cleanup script with a botched SED substitution, and etc. Fail2ban is gone. Here's the critical insight. The daemon is still running on memory state, so don't panic restart. That's how you lose everything. Confirm the daemon's alive, reinstall the package to get distro defaults back, then extract last night's tarball over the top. Always validate with -T before reloading, and reload, never restart, to preserve in-memory bans that haven't hit the database yet. Without that backup, your jail.local survives from jail.conf defaults, but every custom filter and every hour of tuning is gone. Second disaster. You're migrating servers while an active brute force is in progress. Migrate naively and server new boots with an empty ban table. Every attacker on your block list gets a fresh max retry budget. The fix is a timed cutover. 30 minutes out, prep server new with your configs and validate. 5 minutes out, dump distinct IPs from the BIPs table on server old. 1 minute out, bulk import them via Fail2ban client set SSHD banip, so IP tables is already warm. Then flip DNS. The attack keeps hitting a wall and the attacker never notices the move. Third disaster. The SQLite database itself is corrupt, usually from a disk-full event, a kernel panic mid-commit, or that VM snapshot someone took without quiescing the file system. Stop Fail2ban first, then run Pragma integrity check. If it spits back a B-tree page error, you've confirmed it. Try recover into a fresh database and count the rows in bands. If you get a healthy number like the 8421 here, swap it in. If recovery gives you almost nothing, move the broken file aside and untar your latest backup snapshot into place. Start the service, check status, and you're back. Now zoom out. Backups protect one host, but if you're running a fleet, a ban on box A is useless while the same attacker hammers boxes B through Z. You've got 3 patterns to choose from. Push is dead simple. Webhook plus SSH plus Fail2ban client. And it's perfect up to about 20 servers. But the SSH fan-out kills you after that. Pull scales further. One node publishes a deduplicated block list. Everyone cron pulls and diffs at the cost of a 5-minute window. And REDIS pub sub gives you sub-second propagation across thousands of nodes, provided you're willing to run HA REDIS and think about split brain. Match the pattern to your fleet size, not to what sounds coolest. So before we move on, pin this matrix somewhere. You'll find it at 3 in the morning. If all you've got is jail.local, you're back in 5 minutes, but you've lost your ban history and any custom filters. Add filter.d and you're at 10. A full tarball with the SQLite database gets you everything in 15, losing only the bans since your last snapshot. The fleet-wide block list restores active bans in about a minute, but expired entries and recidive escalation state are gone. And nothing. That's 30 minutes of install plus weeks of tuning you'll never get back. With that matrix in hand, let's zoom out at what you actually walked away with from this lesson. 6 concrete skills. You can name the 4 artifacts worth backing up and ignore the distro defaults that don't matter. You can open Fail2ban.SQLite 3 and answer real questions about who got banned and when. You've got a dated, pruned backup running at 3 a.m. via cron. You can move ban lists between hosts 2 different ways. You've rehearsed the 3 disaster types, and you can pick a fleet sharing pattern that matches your scale. Next time a junior ops engineer panics at 3 a.m., you're the one walking them through it. And that's lesson 11 in the books, disaster proof. 4 artifacts identified, daily backup automated, 3 disasters mapped, and a fleet sync pattern picked. Next up is Lesson 12, the final certification. A full 13-lesson skills tree review, all 4 stages end-to-end, and a capstone production checklist before you ship. Load it up when you're ready. I'll see you there.